do, not yet, let me do this first, is you're going to grab some, you miss? Don't touch it. And you're going to make sure that you're going to make sure that it is 60. I should not have anybody talking. I'm waiting for Alondra to just listen. You should have 60 milliliters of each one, okay? So you're going to use the same cup to measure 60 milliliters of each soil type, okay? So what you're going to do is you're going to put each one in a cup, okay? So you're going to use this same cup to fill out the rest. Got it? Okay. I do not want to see you fighting for the material. So do that first, and then I'll tell you what to do next. Okay? I'm just trying to do
Yo, no. Bueno, sí. Ajá.
60 milliliters. Vamos a ver. 60 milliliters. A ver, vamos a preguntarle a la maestra.
No.
¿Cómo le vas a picar?
So once you have already poured the water inside the cup, then you're going to look at the graduated cylinder. You're going to say, I'm guessing, you're going to say, there's about 45 milliliters that dropped in. So I'm going to write in the graduated cylinder, there is 45 milliliters of water. Okay? And how much do you know that you put in? How many did we put in? 50 milliliters. This is how much was poured. And how much was in the graduated cylinder? How many? 45 milliliters of water leaked out into the graduated cylinder. So now we're going to subtract. What's 50 minus 45?
5.
What is it? 5 milliliters. And that 5 milliliters represents what? How much was what?
Absorbed.
Yes, how much was absorbed? How much was retained?
Very good.
Okay? So if you put in 50 and down here there's 45, that means that the soil is holding 5 milliliters of water or retaining it, okay? That's what you're going to do, and you need to have this filled out. Each one needs to have an observation, and each one needs to have math problems in there, okay? Got it? Does anybody have questions?
No.
Okay, this line right here at the bottom, the first one, that stands for 25 milliliters, okay? 25 milliliters. So what are we starting with?
25 milliliters.
Okay. After 25, there is
50.
no, there's 50 at the top. So 25,
30.
30, 35, 40, 45, 50. So after 25, it's going to be 30.
No, 35.
After 30, there's going to be 35.
Very good.
After 35, there's going to be 40. And after 45, there's going to be 50.
You guys
Got it?
understand?
Yeah.
Okay.
Okay, good.
If you have any questions on the measurement, just ask me. Don't guess.
Now tell me your claim again. What do you say? Which soil is going to retain the most water? Okay, now tell me your evidence that you have that is going to retain the most water.
Humans compared to this one, it's more water. And this one is
Okay, what is your evidence? How do you know?
That has more water in the top than in the bottom.
Okay, does the more water on the top mean that it retains the most?
Yes.
So everybody pay attention to this table right here, okay? Everybody look at this table. Put everything down, look at this table. Alright, so they're showing me their evidence. So let's say it loud so everyone can hear this. All right, so the speaker, Alexis, tell us your evidence that you have.
This one has more water on top than all the others, and less water on the bottom.
So when you have more water that's being kept in the cup, that means that it's retaining the most.
Yeah.
So what is this, the humus?
Yeah.
And where's the other one?
That's
And
topsoil.
there's this one. Sand.
Look, this is sand.
Okay, so how much, look at your cylinder. You all write down how many milliliters of water that's being dropped.
I think each line is 5 milliliters.
Oh, okay.
Yeah.
All right.
Give it a baby.
So on your chart, hold on your chart, you all go back to your chart. On the humus, you all write down this right here. We have 50 milliliters poured. So write it down on your humus. I know this is for math, okay? So write down on your chart on the humus, put down 50 milliliters poured. Everybody write it down. 50 milliliters poured.
50 milliliters. I'm gonna write that down.
Everybody write it down on the humus.
Oh, on the humus?
Yeah,
That's how much we poured in
50 milliliters poured, okay? So write it down, 50 milliliters poured. Yes, on your chart, you're supposed to write the word hummus, and you're gonna
Put
write.
that soil in my little paper cup that's acting as my funnel. Okay? And so what do you guys think we're going to do next if we're testing the water retention? We have to add water. How much water did we say that we were going to test with? 50 milliliters. So if I pour 50 milliliters of water into my cup of water, my soil's actually retaining. Oh, I have a call. Alex?
If it falls down, we measure it when it goes, and then we subtract that from the entire 50 milliliters.
Good. So whatever the soil doesn't hold is going to fall into our graduated cylinder, and you can see that there's measurements on the side. So you measure how much water ends up in your graduated cylinder, and then Alex said that we subtract that from our total water. So let's do an example really fast. So let's say I was measuring humus water retention. And how much did we say we were going to measure with? How much water? 50 milliliters. So I would start with 50 milliliters of water. And then let's say in my graduated cylinder, 25 milliliters of water came through. So what would I do with that 25 milliliters? I'm going to subtract it from that 50 milliliters because that's how much water didn't stay in my soil. Okay? So what's 50 minus 25?
30.
25. Good.
Good.
So what does this 25 milliliters down here mean?
How much is put in pounds?
Let me see a hand. I heard a couple of voices. Rachel?
The water that's been put on the soil.
Good. That was the water that stayed in the soil, or how much water the soil retained. Okay, so you're going to repeat that process for all three soils, and then we're going to compare them at the very end to figure out which one held the most water, which one's water retention was highest.